Okay, I think, yeah, now's as good a time as any. Okay, well, good morning, everybody. I think maybe edge computing was too hot of a topic, and so it set off the alarms, and you guys were all a party to that weird event. So thanks for coming back in such a hurry. My name is Kilton Hopkins. I'm standing in for my co-founder, Farah Papiuanu. She's ill today. I'm going to give her presentation. So the next slide describing Farah doesn't look like me. Please don't be alarmed. So what I want to talk to you about today, though, is this trend toward the edge. We've already heard a lot about it, starting with Frederick's presentation right before mine, but we're going to dive into some of the business drivers behind it and some of the emerging technology patterns with it. So, but my co-founder, she's got some fancy degrees, and she's, I like to say, a recovering venture capitalist, but she's also on the Eclipse Foundation Board of Directors, new as of this year. So she's a wonderful person, and shame she couldn't be here today. I will do my best to fill her shoes. So what I want to dive into first is, how is the edge different? Because if the edge were the same sort of environment as a cloud and data center, we'd have a lot of things solved. But if you've ventured at all into the Internet of Things space or edge computing space, you know that this isn't the case. The edge is very different, but why? What makes it so different? This clicker is what makes it so different. So in the cloud, we have high-speed connectivity. In fact, you would not put your hardware and software in a data center that did not have guaranteed high-speed connectivity between all of your different touch points. But at the edge, it's a totally different world. Not only is the connectivity limited, but it's often sporadic. So unless you have a very expensive satellite connection for your backhaul, you may suffer time periods of outages, and that's kind of the matter of course. So how do you deal with that? The architecture, the software that you're running at the edge, this all needs to be able to take into account the fact that connectivity could disappear at any moment, and how do you deal with that? Not my favorite clicker. Great. In the cloud and the data center, everything looks roughly the same. You can buy from many different vendors an x86 architecture, 24-core box with 128 gigs of RAM, and attached network storage, et cetera, et cetera. And you don't really have to think, well, will my software run on this? Because this is standard architecture. And you want everything to look the same. This is the point of the cloud. If I write some code and I want to deploy it, as let's say I have an AI application, and I want to deploy it to spread it out and scale it up in my data center, if I have to worry about which boxes it runs on, then I'm not actually operating very good cloud infrastructure. The edge is exactly the opposite. So if I want to run an application that tells me which employee is currently working on this piece of assembly of an automobile in a factory, and that application runs in the ladies' washroom, is that a very effective way for me to be doing my operations? No. The edge is location specific. You care very much which piece of hardware your software is running on. And in the cloud, not at all. And so how do you make those two worlds work together? That's the topic of today's presentation. It's like a double click. Or keyboard. There we go. So there's a lot of talk about security and IoT. I don't know if you guys have ever heard this joke, but they say the S in IoT stands for security. And pause for laugh. So feel free to reuse it. It's a good one. But it's largely true. You need to add security for yourself. But it's becoming more and more the case that security is being baked in. But think about the edge environment. In the cloud and data center, no one can physically touch your hardware. You would, just as you would not put your stuff in a data center that didn't have good connectivity, you would also not put your hardware and your software in a data center or cloud environment where someone was able to physically access the boxes. But the edge is all about that. In fact, your hardware may be intentionally within arm's reach of the public. And in that scenario, you need to think about security differently. You definitely can't be putting privileged information within arm's reach. So in other words, private keys that are embedded in the box. So if somebody takes the box, they take your key. This is not a good thing. So you have to think about security differently at the edge. And power. And so obviously we have all the power we need in our data centers, but at the edge, you are sometimes operating on a battery, sometimes on a solar charge battery. And you have to consider, well, what would my software do if it got the signal that we're running low on power and we're going to need to save state and shut down? How would you curtail the amount of power you're using if you discovered that the sun didn't shine that much today, you needed to roll back some of your analytics processing? All edge challenges. And so all of these things would be something worth avoiding if the edge opportunity was something small or passing, fleeting. It is not at all. In fact, it is the next place where you need to be. So a lot of things in life are a sine wave. They go this way, then they go back this way. As you could say, it's politics, the length of skirts. There's all types of things that change, back and forth. We went from centralized to client server, it is decentralized, back to now cloud, and very centralized, and we're realizing that you never leave behind what you had. You just go back out and extend it. And the first way of extending for the Internet of Things is to be more present at the edge. This is our opportunity to decentralize a lot of things. And it's a trend that's going to stay until we figure out how to possibly centralize all of that. And how big is it exactly? So estimates show that only about 1% of data at the edge is currently used to its maximum value. And that up to 20% of the data at the edge actually has a lot of value. So a lot of the enterprise data going forward is going to be coming from the edge, but that doesn't mean that it all needs to be brought to some central place in some cloud or data center environment. Much better would be to capture that value where the data sits and then bring the value forward. So you can see some of the numbers here on the growth and the size of the edge market and so on. So some very good stuff. It's the reason we're all paying attention. Important point, edge computing encompasses IoT, and edge computing is really important for IoT, but edge computing is not only IoT. In fact, it's often the merge point between your kind of device-level Internet of Things systems and enterprise systems. If you have in your company any operations, so warehousing, supply chain, manufacturing, chances are pretty good you are doing edge computing today. But chances are also pretty good that you're doing it in a way that doesn't really integrate into the rapidly growing, rapidly changing Internet of Things deployments. And it probably isn't integrated into any kind of cloud or data center architecture where you could merge all of those together. So edge computing's been around a while. It's not just IoT. What we're aiming for, and kind of the reason for my existence in the technology space today, is to produce this, a cloud-to-edge continuum. There really shouldn't be any demarcation point at which you say, now we're not in the cloud, we're at the edge, and everything's different, and that's fine. And that's because every time you have a break, you have huge integration challenges, and you have a lot of cost associated with that. And then you have two different moving tectonic plates that you have to try to align and match up. Far better is if you have a cloud-to-edge continuum in which you can use the same technologies to the best possibility, use the same technologies all the way down to the edge as you have up in the cloud. And if we can produce that, then you can use the same software that you have up in the cloud down at the edge. So a little bit more on what makes the edge hard. I talked about security. I talked a little bit about the connectivity. But so when we get down to the edge, we're often concerned with latency. Either you have limited bandwidth, so there's no way to send all the data back up, or it's too costly, or you're worried about the round trip to the cloud. Does anybody know, on average, how long it takes to go to the cloud and back on kind of an average level of connectivity? What I'd call like good broadband connectivity. Any guesses? Yes, what was it? I heard it. 40 milliseconds is actually really good. The one you can expect is probably about a quarter of a second. I thought you said a fourth of a second. 40 milliseconds is great. And if you can get it consistently, it's probably because you're hitting something on the edge of the cloud that's kind of in the urban ring of fiber connectivity and so on. But 250 milliseconds is what you could expect to kind of go into the center of the cloud and back. And oftentimes in manufacturing processes or in safety systems, you're going to need performance that's sub 1 millisecond if you really want to get near real time. You also have this problem of lack of flexibility. When you go out to the edge, you install hardware. It's expensive to go and install it again. So if you install something that doesn't lean into your future, but is a point-in-time solution for just what you're doing right now, and in 6 months or a year you realize you need so much more from it, and you send that field worker back up the ladder, back up in the bucket truck to go and replace that hardware, you're spending a lot of money on something that you maybe could have foreseen. So getting the right edge infrastructure in place is going to help you overcome this challenge of the edge. But you don't just rack and stack servers like you do in the data center, wire them up, and then virtualize them. At the edge, you have to send people to very diverse locations. So what we really want at the edge is we want this platform stability. What we've come to expect from our cloud systems, and what we end up with instead is vertical silos. Vertical silos can be very efficient. They do have some advantages, right? Things in a very clearly defined vertical stack tend to work very well together. They don't work well across silos is the problem. And that's how you end up stuck with systems that don't interoperate. And what Frederick said was, you want to have, once you get up above the edge environment, you want to have messaging systems so that you can leverage what you're doing in greater numbers and across different systems. And I would say, if possible, if you can start that at the edge, then you're in even better shape. And what we also get is, and pardon me if this offends anybody, but I am from a rural area, so I think this is pretty funny. That's basically how I grew up. So we get architecture that are pieced together. And architecture at the edge is a very dangerous thing, because when you take something from one vendor and you say, oh, well, we can implement a protocol translator and then it will talk to this other thing, what you have is you have a whole bunch of inner workings that are fragile. And that doesn't give you that pyramid of stability, but rather something that collapses as soon as you add one more piece on top, down, everything goes. We would really like a seamless developer experience. So is anybody in the audience, would you consider yourself an edge developer, an edge computing developer? Anybody have that title? Great. Small number. You're probably in high demand. Most people would like to take the skills that they already have and be able to leverage them at the edge. And so what unfortunately we have, though, today is something akin to the earliest days of our computing world. And we have the equivalent of the Homebrew Computer Club, which is you need to learn a lot about the inner workings of the hardware you're on and so on in order to make things work at this time. This is, however, about to change. And so I think that's actually a good time to show this. Does anybody have any of the NVIDIA Jetson series edge computing boards? I know you've got a lot of them. Yeah. So this is a NVIDIA Jetson Nano. This is a $99 board. It has a quad-core ARM processor in it, 64-bit, 4 gigs of RAM, and it has a GPU. That's the important part, is that it has a GPU. And because it runs a Linux operating system, you can use, I so happen to be the creator of the Eclipse IoFog project, which is edge computing using containerization and so on. You can run the same stuff that you run in the cloud right on this board. Now, that's very difficult to do without some kind of an edge computing framework. That's kind of the area that I'm focusing on. But just think, if you take what it is that you already have and run it in this board and have a way to manage it, you can leverage all of the skill set that's already on your team. So the compute, the analytics, all the stuff that you wanted to do in the cloud should be able to be moved right to where the data is, and you should be able to do it seamlessly. And even, by the way, this runs on 10 watts of power or less. So it's actually suitable to be powered by a battery, although just barely. Contrast that with your average computer, and it's more like a 60-watt deal. And this little module runs off of a coin cell battery. And this has a label on it that says TensorFlow, powered by TensorFlow. And that's because this module is a $25 module. When attached to some kind of an edge board, such as a Raspberry Pi, or it would work well with the Jetson Nano, it's capable of doing real-time natural language processing all off of a coin cell battery. And so what we have is the software models of the cloud. What developers really need is software models of the cloud being brought down to the edge, and that way we don't have to retrain everybody in order to take advantage of the edge opportunity. So this is a slide from my company and the Eclipse IoFog project. So you should be able to bring your own edge. And that means define what hardware do you need at the edge to accomplish your use case. You shouldn't be saying, I have an IoT platform and it supports the following boards, and I guess those boards are capable of working with maybe a small resolution camera, so I guess we'll do that. You should be saying, I would like a camera that gives me 4K video, can process, do analytics against that video in real time, right on the camera. Then I would like that information, the results, to become part of my enterprise data stream. So define it for yourself. What do you want? So you should bring your own edge, define what it is you want at the edge, and the rest of the stuff runs on top of that. All the software is common. So what we're aiming for with edge computing, if we have a true universal edge compute layer, is to be able to run any software on top of any hardware. And any software means what you've already got. It means stuff that you would prefer to write in your regular language. So if you're a Node.js developer, use Node.js at the edge. If you're a Python developer, use Python at the edge. And if you use PyTorch or TensorFlow or any of these things, you should be able to use those at the edge as well. Also, we have some Eclipse IOFOG users that have code that is 12, 15 years old, some of it in C++, some of it in C#. Taking it and packaging it to deploy to the edge is sometimes just a 1 or 2 hour task. So imagine if you could actually say, well, we do all the processing, I just wish it was closer to the source of data. Why not just take the code you've already got? Try packaging it up and pushing it out. Might work. Should work. So patterns for the edge. There are 4 things that you must accomplish in order to make edge computing work for you at scale. This is a bit of an oversimplification. I can talk about this stuff on and on, so if you want to dive in deeper, we can always catch it in questions or afterwards. But the first order of business is to make the edge intelligent. And this is kind of table stakes for edge computing, right? This is, I want to run the software closer to where the data is. And if you can do that, that's great. That's a great start. But it leans right into management. So if I have a dozen edge nodes, I'm doing a proof of concept in my factory, and I've decided to put some data analytics there and use Python for it, I can probably manage those dozen nodes myself with SSH over the network and get in and change things. Now scale it out to 10,000 nodes. And that's across 100 customers. And that's across 5 different countries, geographies. This is where management in the framework, in the edge computing framework, is necessary, because otherwise what you have is a proof of concept that's still 3-4 years out from being ready for production. The common layer of edge computing should not be written over and over again. How do you manage the software that's running on 10,000 edge nodes that's in what I call your edge compute network? That should be done for you. You shouldn't be thinking of that as the business solution developer, right, as the developer for the edge. Getting everything connected. So there's a first order of business. Give a connection to things. Give a physical connection. That's most of what is discussed when we talk about IoT, right? Give a cellular modem connection to a sensor or give a Wi-Fi connection. That's not sufficient. The connectivity that I want to talk about is from edge to cloud, from cloud back down to edge, and from edge to edge. Because it doesn't do a lot of good to just keep funneling everything up when what you really want to do is pass it around and do some in-building processing before you finally decide what needs to go to the cloud. So if I have one camera that sees that someone's in a part of the factory they're not supposed to be in, I should be able to pass that information to the cloud if needed and to other things within the building. Maybe gate lock systems, maybe a monitoring system, maybe another camera to say, you might want to turn this way because I saw something down this hallway. All of these things are edge-to-edge communications. And the way that you interconnect everything doesn't make a lot of sense to give everything an unfettered internet connection and then have a whole bunch of open ports everywhere. Far better if you can have something like this concept of an edge compute network. Point-to-point communication between all of the things, whether they go from edge to cloud, cloud to edge to edge, such that you know that it's encrypted communication and peer-to-peer, and you don't have to worry about a truck that's driving down the road having open ports that somebody can try to attack, or your warehouse needing to have open ports so that truck can communicate with it. Far better to have things point-to-point encrypted. I talked a little bit already about security, but a couple more points on it. If you take secret information and you put it in edge devices, if those edge devices are physically compromised, there's a chance that somebody could get that information. I happen to have experienced this personally. Spent some time as an IoT advisor to the city of San Francisco. We had an incident that really opened my eyes as to the way that you should be embedding information at the edge and trying to protect it. It's okay to use public-private key pairs and all of that stuff. Of course, that's really great technology. But the way that you apply it and the way that you assign it, such as what they think about a VPN, do it carefully. You don't really want to have a whole bunch of static connections with a lot of privileges out there. You definitely don't want private keys baked into devices that somebody could just take off the wall with a screwdriver, take home, plug in a USB cable, and try to get that private key. That's how people just kind of walk right into the back end with a false sense of trust. Maybe you could assign the identities or allow something on your edge compute network after you've proven that it actually is the right hardware and it's running the right OS and so on. So that's thinking a little bit differently about security at the edge. And of course, Eclipse IOFog has all of that built in, which is why I'm talking about it, is because we've researched it. Now, the edge is everywhere. I'm going to walk through some use cases here, a couple of different customers. One I'll give by name at the end. So a lot of telecommunications uptake with edge computing. There's several reasons for it. One is that they are the data flow path. If you're operating cell towers, chances are pretty good that you are right in the position to be running microservices at the edge or at the near edge. And if you're a telco company that operates a cellular system, you could be AWS for the edge. Why are you not charging your customers to run their software closer to where their data is flowing? It's a great opportunity. I don't think that you should design the edge computing. I think you should design the application infrastructure to charge your customers. So in this case here, broadband customer premise devices, Wi-Fi routers, are a great opportunity for edge computing. They're already in your customers' locations. Why are you not deploying applications to those and improving customer service or allowing applications to run in the home close to where the data is? So that's interesting. An extension of that is in a wired topology, telco companies that have been maybe a little bit commoditized over the last years, finding that people really just want the data to move through them and get up to the cloud where all the business is. You can reclaim some of that value. You can make yourself relevant again. Your central office in your wired topology is a perfect place to be offering edge microservices, high value. So that 40 milliseconds, what if you could guarantee that 40 milliseconds to all of your business customers because you've got the wiring in place and they just need to know where do I run the software. So a lot of opportunities for using Eclipse IOFog or whatever it is you use here, but a lot of opportunities at the edge. And so another telco, think smart city here. If you're running edge microservices at the cell tower and on the devices, you have kind of an unbeatable team. The camera sees something of interest. Maybe it does license plate recognition. Doesn't send the picture, sends the text. Keeps the picture if you need it for an audit, but just sends the license plate and whatever is the violation, right? Rolled a red light. At the cell tower, we're aggregating information, all cameras across the whole city. What goes up to the cloud is only what's really relevant on an aggregate level, and everything else stays below. So multiple touch points of edge computing. The edge is everywhere that you need the processing. It's not one place. It's not just the IoT gateway. Sometimes it's the device itself. Other times the devices are really simple, and they speak LoRaWAN, and they're only sending over 4 bytes of information at a time. They can go ahead and send that, and you can pick that up, that low-power wireless, and do some edge computing wherever that base station is. So you put the edge computing where you need. And so in hospitality, you hear this mentioned a lot. I would like to do better predictive maintenance on my equipment. I would like to offer better service for my customers that bought my product. I would like to give software updates, all of these things. So this happens to be a user of Eclipse IOFog that is in the space of exercise equipment, or a global leader in manufacturing of that equipment. Up until now, updating their equipment has been a matter of doing a firmware update, and often they do it via sneakernet. You guys remember the term sneakernet, right? It's basically, I'm going to walk up, I'm going to put in it used to be, I'm going to walk up and I'm going to actually, use the parallel port and whatever. Now it's, I'm going to use a USB flash drive and I'm going to load some software. That's the world that they're coming from. And the world they're going into is having their customers say, well, I have a Bluetooth wearable. Why are you not picking that data up? Do I really have to grab the handlebars on this thing? Like, why aren't you reading off my Fitbit? All of these things are great if you have a software model that makes sense. But if you don't, you end up spending all of your time figuring out, how am I going to work with the Bluetooth stuff? That should just be done for you. Build the business application. So let's dive into one particular customer. This customer is a Japanese company called Japan Radio Corp. It's about the same size as Motorola Solutions. And what they've been using Eclipse IOFog for is to address, starting to address some issues in the oil and gas sector. And they provide private LTE. So think if you had your own cell network that was just on your oil rig, you would have really good connectivity with a certain guaranteed amount of bandwidth and private, encrypted communication. It's all very good, but then you still need some way to work with the software. And so automated fire detection is something that I'm going to list like some different use cases for oil and gas that are edge computing specific. Automated fire detection. So if you can find smoke, flame, excessive heat in a facility on an automated basis, you know where it is, and you can alert all of the other systems at the edge, you get a leg up on an outbreak of fire, something corrosive maybe has caused something to leak, and you get a heads up on it. This can save you a ton of money. It can save lives. Emissions monitoring. So again, you're going to have small devices, probably battery powered or maybe solar charged battery powered, and they're probably going to speak over some low power wireless because you're going to have a lot of them. The more sensors you need, the cheaper they need to be, and the less likely they're going to have big batteries and a lot of compute, right? You want them to be compact. They're going to be more like these modules here. So you're going to track emissions. Well, you're going to aggregate a ton of information right there at the facility. So if they're chirping once per second, even once per minute, and you have 4,000 of them deployed across the facility, that's a lot of data, and you need to be able to take it in, process it, and see are there any anomalies, and you want to check them right there at the plant. So if you already have video cameras in place, maybe you have them in place because you are doing security monitoring, or you're using them to do image recognition for that fire detection, why not also do some compliance detection? I mean, you've got a camera, you've got a GPU there at the edge, I hope. Maybe you're using one of the Jetson Nanos or Jetson TX2 or Jetson Xavier. Whatever you're doing, why not also add the use case of saying, well, as I watch the people go by, I can count employees, I can see how much work is being done in what sector, but I can also see if I'm finding hard hats. Or maybe there's a special color safety vest that someone's supposed to wear and you don't see it on some personnel, and that allows you to get a heads up on that. So one piece of edge hardware, many use cases. Pipeline monitoring, very similar to emissions monitoring. A whole lot of sensors deployed, high accuracy readings, needing to take that data in and work with it where there's no connectivity. Life extension of equipment. And we chose for this the offshore rig as an example because when you have an outage, it's not just a matter of saying, I'd like better usable lifetime out of this equipment. In some cases, one piece of equipment goes offline and everything goes offline, sometimes for an extended period of time. And if it's an offshore system, you're probably then waiting for someone to come out and have the right technicians come out and recertify everything so you can reopen. So safety first in those situations often means a lot of money is lost if you don't keep things up and running. And then, of course, thermal monitoring here, and that would be a pretty easy flame to detect, if you ask me. Although a lot of that stuff is they flame out on purpose, but yeah, so good use of AI. Cool, so that's some about the trend toward the edge, some about how the edge is being architected, and then a lot about how it's being used. And I'm not sure, because of the emergency situation, what time we have for questions. Keep going? Okay, looks like we've got some time for questions. Why don't I take a few, and then we'll see where we clock in. Yeah?
So you had mentioned an architecture for allowing supporting things like low latency and having seamless integration across the whole litany of things. Were those comments based on where you see technology now, or how does that change for 5G?
Mm-hmm. Okay. First, the comments are about where technology is now. It's not a future state that we're hoping will come into play. It is the technology is there to be able to treat the edge like your cloud or like your data center and to have the seamless type of integration. Now 5G, that's a term that means a lot of things to a lot of people. But there's one thing that we all know for sure about 5G. It's higher connectivity, higher bandwidth, and supposedly at lower cost, right, for like kind of an individual device to be able to send data. With higher connectivity, the impact that 5G is going to have on all of this is it actually is going to make the edge even more attractive. Because if I can get a less expensive connection that is cellular based, right, so meaning that I can put it out on the open road and it's going to have good connectivity, good bandwidth, I would be more attracted then to putting the data there in the vehicle or on the machinery, or put the software rather to work with the data, because I have some reliable connectivity that allows me to get back the results and so on. So I would trend more toward the edge with 5G. I think it's a huge enabler. And on top of that, there's a reason why a lot of telco companies have been coming to my company in the Eclipse IoFog project to talk about their needs, is as 5G begins to roll out, they're realizing that the software model needs to be very different than this cloud-centric one, because the whole purpose is to have a lot more going on in the physical environment, and how on earth do they run software there? So it's, those two things are pretty interlinked. Yeah, cool. Yes. Oh, sorry, with the microphone, but we'll make sure we get to you next. Yeah.
That's fine.
Okay. Okay. Either way, this time for definitely both. Or it was on. I think it's on now. Yeah.
Yeah.
Okay.
Questions. One, so the edge is like one-to-one with the IoT device, or it could aggregate all the IoT devices with the surrounding and one edge server. First question. Second question.
Okay.
Where do you find the sample implementation of the edge use cases?
Okay. Could you say that second question one more time?
No. Where do you find the sample?
So like a reference architecture and so on. I encourage you to look at the Eclipse IoFog project and look to the Eclipse Foundation. There's a lot more material is starting to be surfaced on the project pages and the Eclipse Foundation website. But worst case scenario, reach out to anyone at Eclipse Foundation, or you can reach out to me personally. Happy to give you my card to talk about reference architectures and implementations. There are standards emerging for sure, and best practices have kind of already arrived, but there is definitely no definitive architectural approach where it's like put this here, put this here, put this here. And so leaning into that, then your first question, which was, is it a one-to-one or a one-to-many relationship? I wish I had a big whiteboard here, because this would be a fun session. You want to roll up data from the edge toward the cloud in a way that makes sense for your use case, that looks something like this. The lowest level devices are going to have probably the capability of doing some sensing, but they don't really have an enterprise data context. Maybe it's a temperature and a moisture reading from the edge of a crop field. But if that sensor needs to have all this enterprise information in it, like what's my sensor ID, and what's the synchronized timestamp for all of this data that's coming from the enterprise backend, that triples the amount of data it needs to send right there. 4 bytes for the temperature, 4 bytes for the moisture reading if you're going to have kind of some good decimal points in it. 4 more bytes for the time, 4 more bytes for the identifier, if not more. Why would you add all that data to the 10,000 devices? So you add context as you go up, and your edge nodes should be capable of handling many of the underlying devices. Now, if the device is something like a camera, video camera, chances are pretty good that you're going to do the edge computing right there. And then you've got a one-to-one with the edge compute and the device. So I hope that makes sense, but there's a lot of different permutations. And then as you go up, you roll up more and more. So we had one there and then one there as well. We'll get to both. Yeah.
Thank you. You had some oil and gas examples up there. Have you looked into the area classification requirements that are inherent in the oil and gas applications that you had?
So let's talk about one of these rod lift donkey pumps, they call them, right? It's up and down out in the field, and you've got 2,000 of them out in the field. There are specific zones of interaction that are allowed, right? And the outer limit is where you're probably going to find your easy to maintain stuff, but your sensors have got to go on that physical thing. That's a zone 1. So you get into these, and this is kind of universal across all industries. Every industry has specifications about what's allowed to run where for safety reasons and so on. If you're going to put an edge compute node out in the oil field, the person who installs it is either going to need to be a certified oil and gas electrician, $400 an hour plus, and therefore you want to put it out there once and be done, or you're going to use something like a cheaper approach, which is the sensors are in place, they've been in place for a while, but it's all this kind of closed loop system. Maybe you can tap into the data flowing there at the pump with the controller that's in a zone 2 or zone 3. There you just need to wire up to the serial port, add your edge compute there. A lot less expensive if the sensors are already wired up. But if you need new sensors, then you're into that tough zone. So in every industry, you need to ask yourself, what's the value of the data? What do I need to install to get it? And what can I install today that will be good for 5 to 10 years? Because I guarantee you're going to have new use cases after you do your first deploy. Someone says, I just found this AI model. It's going to give us analytics ahead of time on blah, blah, blah. And you say, we were just there. We were just there a month ago. We can't get it out there. But if you've got some good edge compute, you just push button deploy, and out it goes. Yeah, cool. Yeah. Also, explosion proofing is very important. Yeah, and then I think we had, yeah.
Can you explain, and you might have already, so I apologize, about Edgeworx specifically? So do companies do business with you guys, or is it the IOFOG? Like, how does that,
Sure.
how is that interaction?
Yeah, and this is a good thing to talk about because it would go for any other company that is a sponsor of an Eclipse project, right? So the company is called Edgeworx, and Edgeworx is we are the creators of the Eclipse IOFOG edge computing open source layer. We are heavy contributors to, heavy maintainers of it, but not the only ones. And we've guaranteed that all of the open source layer will remain with the Eclipse Foundation. And so what we do is we build stuff on top of it, just like you can. And so what we try to build is the stuff that everybody wants, maybe a really great GUI for doing management of your edge nodes, or some tools for doing AI stuff where we get your models trained really easy and pushed out to edge nodes. But all the stuff is on top of that open source layer. And so that commitment's done, and Eclipse IOFOG is there for all of us, and we use it too now. But we are still the majority of the maintainers, and will be for the foreseeable future. Yeah, cool. Yes and yes. And I think then for that, I'm not sure on time, but maybe it'll be time to wrap up.
Okay, so you take us right at the edge. You come in as a developer or maybe an installer at that level. I have 18 depots across the United States.
Mm-hmm.
If you come into one of my union shops and attempt to touch a machine that you don't, right, there's a legality issue.
Yeah. Mm-hmm.
I've got to find out first that you have the legal rights to touch that machine and put anything on there that needs to happen.
Sure.
Have you encountered that? Can you tell me what the time frame is that it took you to get it resolved from your company to my company in a normal sense?
Yeah, so the best path forward, I have encountered this, and the best path forward is first you should be doing some kind of a proof of concept so that you're not coming into active facilities and saying, okay, everybody, we're going to deploy this, and it's the first they're hearing of it. That's not good. What you really want to do, if you've got the opportunity, take the people that are the normal owners of the equipment maintenance, right? The people that are authorized to do it, the people that are this is their normal job, and bring them into the proof of concept to show, here's what we've got working, now how would we roll this out and deploy? Chances are pretty good it's the union labor, it's the IT staff as well, and it's probably the business line manager who's in charge of the operations who's going to be involved. And a small POC with a couple pieces of equipment, I'm sure you have test facilities somewhere to try out things before you would roll out new models. No, you don't. Okay. If you can get that in place, it's going to pay great dividends, because otherwise the time frame is let's start, then red tape for I don't know how long, 6 months, which with a POC, a little bit of red tape, you get all people together, pick one depot as a test facility, and then everyone's on board and you figured out the rollout problems before. You're still going to encounter a couple months of getting it, but everybody has to work together to do it, and I think getting people involved early is the right model. Yeah, sure.
Okay, so sorry, I will be forced to yeah, absolutely. We'll have a Q&A session at the end of the day with all of the speakers, or you can chat directly with Kilton.
Yeah,
but we need to let the next speaker get prepared, so
okay.
Sorry about that.
Okay, thank you, everybody.
Thank you, Kilton.